So 23 says a wooden raft has a mass of 55 kilograms. When empty, it floats in water, which has a density of 1,000 kilograms per cubic meter, with 64% of its volume submerged. What maximum mass of sand can be put on the raft without sinking it? So we know that we've got 65% of it submerged under the water. So this is a buoyant force type question. So right now it's floating, which tells us what about the upward and the downward forces?
They're the same.
They're equal. So here's our center of gravity, got a downward force, and we've got an upward force. We know that the downward force is equal to the mass of the raft. Does it give us that number?
55.
55.
So 55 kilograms times 9.81 meters per second squared.
539.55.
Up here we've got buoyant force, which is going to be equal to the mass of water times gravity.
So is this the same thing as density of water times the volume displaced?
Good. So we can also say density of water times the volume of water times gravity. So we know that the density of water is 1,000 kilograms per meter square or meter cubed. The volume we don't know right now, so we'll leave that as a variable. And gravity we know is 9.81. And we know that these three things multiplied together need to give us this same number.
So we can find the volume, huh?
Yep. And so if we find the volume of water, we also will find the volume of 65% of the raft.
I got the volume 3.055.
So let me double check, yeah. Divide 9.81 by 1,000.
0.055.
I got a different number. 539.55 divide 9.81 divide 1,000. Okay.
So now we can figure out what 64%. Times
Meters cubed.
35. So that's the total volume. So the volume of submerged.
Yeah, so now we know that
Would be
the volume of our raft times 0.65, so 65% of our raft equals 0.55 cubic meters. So if we want to find out what the full volume of the raft is, we divide that by 0.65.
Oh crap. That's just the volume displaced, huh?
Yeah.
So,
So that's the volume.
And 64%.
Oh, 64.
Yeah.
This seems really small.
displaced volume. So that's how much water, that's how much the volume is in the water, I take it?
Yeah. So 65% of the raft is in the water, which means whatever 65% of the raft's volume is, that's how much volume of water is being displaced. Or 64, I'm saying 65. Let me double check this though, because that volume seems really low, which I guess is possible, but I would expect a raft to be bigger. density of water times the volume of water times gravity.
So what would you get the total volume to be if you did that times
0.0859.
0.08? Just take 0.055 times 0.64.
Divided by 0.64.
Should be the total volume.
So the total volume of our raft equals 0.0859. Cool. So that means that we can submerge, so if we pack this thing full of sand, we know that more and more of it is going to start to go underwater. So right now 64% of it's underwater. As we throw sand in it, we know it's going to sink lower and lower into the water. And we can keep throwing sand into it until the water level is just equal with the brim of our raft. That would be the absolute maximum. And then if we throw a little bit more sand in, then water will start coming into the raft and then we'll sink. So we can submerge, theoretically, 100% of our raft so that the top of the raft is just equal with the water level. Obviously that's not very smart, because then if you just tip a little bit, you're going to get water flooding in. But if it's asking for the maximum amount of sand, that's kind of the theoretical goal that we're heading towards. So if we do submerge 100% of our raft, so all 0.0859 cubic meters, then...
So now that's how much we're basically displacing.
Exactly.
So that's going to be the volume displaced times
Yep.
the density of the water
Exactly.
times the gravity.
Exactly.
Okay.
So if we submerge that much of our ship, or our raft, then that means that we displace that much water. So then the buoyant force would become, in this theoretical situation, it would become the density of water times the volume of displaced water times gravity. So it would be 1,000 times 0.0859 times 9.81. So the maximum buoyant force that we could observe would be 843.0 newtons of force.
Now all you gotta do is take that divided by the gravity, and you get total mass of the sand.
If we divide this by gravity, then we get total mass of the
boat
raft
and sand.
and sand.
So then you subtract
Yep, so we'll
55.
divide that by 9.81. So that means that if we displace this much water, it would be capable of holding up something that weighed 86 newtons, or 86 kilograms. So that's the maximum amount of mass that we could hold with that much displaced water. And we know that 55 of those kilograms are going to be from the boat. So everything else would be from sand. So it'd be what, 31?
31.
That's cool.
Is that the right answer?
Yep.
Makes so much sense. We have a tutor.